I have joined it, and but my name is coming under the attendees.
I can see you in panelists, sir.
Okay. Okay, Dr. Chopra, I am ready to join. Should I upload my PPTs?
Yes, sir. You can keep it on that screen. You can keep it ready. Our team will give you the sharing rights. Please check it once whether we can smoothly have your PPT on the screen.
Dr. Chopra, we are uploading it.
Yes, sir.
Just, I will take half a minute.
I can see your screen, sir.
Dr. Chopra, we have uploaded the slides.
सर नमस्कार.
Thank you.
I can see your
कैसे?
screen, sir.
Sir, it is a great pleasure to meet you again.
It's my privilege, sir.
So kind of you. Thank you.
My pleasure.
I'm just learning.
It is your greatness that you say I'm learning. Of course, every moment in the life is learning. But you have inspired many others like me.
बेटा इसको देख ली.
Sir, I can see your screen. Your screen is visible. We can see your slide. A very pleasant evening to all the panelists and the participants connected with us. It is a pleasure to connect with you all. I welcome you all for today's session on the topic e-science and e-research, practices and potentials for science and research in digital age. Our expert for today's session is Professor Manohar Lal sir. Sir has already joined us. We will be starting in a while. This is for your information, dear participants, that the recorded video of this session shall be made available on our YouTube channel at the earliest possible, but by the end of this session. The details of our BVI CAM YouTube channel will be shared on the chat window during the webinar. Also, more important details will be shared on the chat window itself. Further, I request you, dear participants, that whatever device you are connected with for today's webinar, please ensure that you can access the chat window, as chat window is an important mechanism through which we will be communicating during the webinar. Any questions you will be having, I will be facilitating those questions by asking those questions but the end of this session. Also, dear participants, we will be sharing a feedback form link on the chat window for automated generation of the certificate of participation for today's session. Dear participants, the link will be shared during or by the end of this session. So stay connected with us till the last of this session and own yourself a certificate of participation despite increasing your knowledge. I request you all, dear participants, to please ensure that you can access the chat window. You may find the chat window on the right-hand side of the screen. Also, dear participants, to ensure the same, you can write us your name and your area of expertise for better networking and also for ensuring the same. Good evening, Subramaniam sir. I welcome you for this webinar.
Good evening, ma'am. Good evening, good evening.
Good evening, sir. Dear participants, this is to inform you that the recorded videos of our activities are available on our BBI Camp YouTube channel. Also, the recorded video of this session shall be made available on our YouTube channel at the earliest possible by the end of this session. I request you all to find the details of our YouTube channel from the chat window and subscribe the same for regular updates. Very pleasant evening to all the panelists and participants connected with us. It is a pleasure to connect with you all. I welcome you all for today's session on the topic e-science and e-research, practices and potentials for science and research in digital age. Our expert for today's session is Professor Manohar Lal sir. Sir has already joined us. We will be starting soon, dear participants. Dear participants, before starting, I would like to request you to please ensure that you can access the chat window. Chat window is an important mechanism through which we will be communicating. Also, all our related important details will be shared on the chat window itself. You may find the chat window at the right hand side of the screen, dear participants. Please find the same and ensure that you can access it.
Ayushi,
Yes, sir.
let's start, please.
Okay, sir. A very pleasant evening to all the distinguished panelists and the participants. Bharati Vidyapeeth Institute of Computer Applications and Management in association with Computational Intelligence Society, chapter of IEEE Delhi section, Computer Society, chapter of IEEE Delhi section, Technology and Engineering Management Society, chapter of IEEE Delhi section, System, Man and Cybernetics Society, chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity Group of IEEE Delhi section, Life Member Affinity Group of IEEE Delhi section, Inter-Society Relations Standing Committee of IEEE Delhi section, Industry Relations and Special Interest Group on Humanitarian Technology, Standing Committees of IEEE Delhi section with the associations Computer Society of India, Institute of Information Technology Professionals IITP, ISTE Delhi section and IETE Delhi Center as technical collaborator, welcomes you all to the webinar on the topic E-Science and E-Research, Practices and Potentials for Science and Research in Digital Age. It is a moment of pride and honor to announce that we, with united hands, mark special contribution for the monumental occasion Azadi Ka Amrit Mahotsav, an initiative to celebrate 75 years of glorious independence by organizing the thought-provoking sessions for our better future. This webinar is an initiative for the celebration of Azadi Ka Amrit Mahotsav. Clearly, the thing that's transforming is not the technology. It's the technology that is transforming us. E-science and e-research have tremendous potential in conducting scientific investigations to uncover novel instances of scientific knowledge in the form of facts, laws, theories, or models and their explanations. Additionally, the immense computational speed, ever-expanding repertoire of computational assets of tools, approaches, and strategies have also opened new vistas for scientific enterprises and have given rise to a number of new paradigms for pursuing scientific investigations and research. Two new paradigms, simulation and data analytics, over and above the earlier paradigms of theory and of controlled experiment, have advanced the theoretical and experimental progress in many areas critical to society, including the domains of advanced biotechnology, energy systems, nanotechnology, and environmental modeling. These paradigms also offer hope for progress in answering some of the almost unanswered questions regarding fundamental structure of matter and the origin of universe, etc. This webinar aims to explore the issues in e-science and e-research in the current digital age. Also, it will discuss the all-round perspective of the same. I would like first like to take this opportunity to ask our panelists for we are privileged to have amongst us a galaxy of experts. I welcome all of you. I now request Professor M.N. Huda Sir, Director, Bharati Vidyapeeth Institute of Computer Applications and Management and Vice Chairperson, IEEE Delhi section to address the concerns with this. Please, sir.
Good evening, one and all. At the outset, I take this opportunity to welcome my elder friend and a true teacher who keeps on inspiring all of us, Professor Manohar Lalji, for having agreed to my request for being a valued speaker and enlightening all of us on such a novel topic, e-science and e-research, practices and potentials for carrying out science and research in digital age. I also take this opportunity to welcome and pay my gratitude to all the participants from different parts of the country who have already joined and who will be joining maybe few time from now, because this has been a tradition that now people have come to know that certificates are, link of the certificate is being at the last, so they keep on waiting for that. So thank you so much. Dear friends, the topic which you see, for this topic, there could not have been a better choice than Professor Manohar Lalji because a very simple reason. He has seen close to last 6 decades very closely. When he has started, he might have started his research at that moment. Dealing and settling with anything in computing domain was almost unimaginable and very difficult. From that, maybe around 6 decades ago, from that beginning, the changes have happened to that extent that now we are talking of e-science and e-research. How the science has got transformed themselves to e-science, how the research has transformed themselves to e-research, and that too on the top of it, the cap of digital age. So if all of us do not change ourselves and remain in that era, maybe around 5 decades, 6 decades ago, then probably we are mistaken. Has changed to e-science, research has changed to e-research, and on the top of it, the cap is digital age, so we also need to change. Probably now, the things for which the professors earlier used to ask scholars to work months together, and themselves the professor used to work for almost weeks together to understand that whether the topic which the scholar is selecting, what kind of researches has been done earlier and what is the present state of the art. That aspect has become very easy. But when I'm talking with this aspect has become easy, the challenges to all of us are more. At that moment, we were not aware about the latest problem. Most of the time, we used to perceive that this could be the problem. But now we are aware of all these problems because of the digital age. And the digital age is such an age which has transformed the world at much more faster pace than any other age with which we have witnessed. And that's how, my dear friends, I keep saying that इंसान घर बदलता है, लिबास बदलता है, रिश्ते बदलता है, दोस्त बदलता है, फिर भी परेशान क्यों रहता है? क्योंकि हम अपने आप को नहीं बदलते. And that's how Ghalib said that उम्र भर गालिब यही भूल करता रहा, धूल चेहरे पे थी और मैं आईना साफ करता रहा. So all of us will not be blaming the technology. आईना साफ करने से कुछ नहीं होगा, टेक्नोलॉजी को ब्लेम करने से कुछ नहीं होगा, रादर हमें अपने आप को चेंज करना पड़ेगा. And the maximum potential of the technology, that is what is the topic, the practices and potentials in digital age. The maximum potential of the technology we have to unleash, and unleash to the extent that the researches which we are doing, that advantage of the beauty of the digital age should go to the researches. And one more aspect, because the topic has already been introduced by Ayushi and we have such a learned speaker today to talk on the topic. So one more aspect which I wanted to sensitize to all of you, I was seeing the profile of the attendees and I could see many research scholars, many young teachers, many MTech scholars, that whatever topic we are selecting for the research, that should be translational into the nature. And now understanding the value of translational is very easy. It might be possible that sometime the scientific value, sometime the actual algorithmic value of that translational research is less because of its applied nature. But the kind of the societal impact that translational research will create in the society, that probably will only bring the advantage of the research, and particularly the advantage of this digital age, with the help of the digital age, the advantage of the research in our day-to-day life. And unless this research is not coming to improvise our quality of life in day-to-day affairs, probably the purpose of actual research will be lost. So the advantage which we are having of the technology should be brought for the purpose of improvising the overall quality of the people, overall quality life on that. That's more important. And that's how I keep saying always that the purpose of the scientist is to show the path, that this is how it is possible with the help of the technology and this thing can be developed. But purpose of the engineers are to ensure that how that research potential, how that innovation, how that technology which has been suggested can be leveraged, that potential can be leveraged, that advantage can be brought to that extent that a product or service connected to that environment, product or service connected to that technology should be brought to the market, so that the ease of doing, so that the quality of day-to-day life, so that the finally at the end of the day, the people who are going to face problems day in, day out should get their problem resolved with the help of the technology. And proliferation of the technology, no other age except the digital age can be such a boon. So with this note and with this background, that today's webinar is not just a technical lecture. We are organizing now these webinars since last May 2020 at the backdrop of 75th celebrations, 75th year celebrations of the independence of the country. That is what we claim as Azadi Ka Amrit Mahotsav. This webinar, this technical lecture is also in its sequence 75th. Professor Manohar Lal sir, this is 75th webinar of 75th year independence of the country. It is such a coincidence. So from now onwards, we'll be naming the sequence 75th, then 76th, then 77th, etc. So today, 75th year of independence, we are having 75th technical lecture series. And for us, the speaker, none other than Professor Manohar Lalji, who has inspired thousands of teachers and thousands of individuals like me. So let's welcome to him and let's listen from him, who has seen 6 decades of computing in the country, locally and globally, and no one can be a better than him from teaching community to inspire us and tell us that how the technology was 6 decades ago and how the technology is now. If you ask me, I have seen only 3 decades, but he has seen more than 6 decades. So he will be in a position to make us to understand in a better way. So thank you so much for accepting our request and being with all of us. And dear participants, there are many, around 8 webinars which are already notified for the purpose of registration. If you have not registered so far, please register. First, second, that we have got a YouTube channel where recording of all these webinars are uploaded and earliest possible uploaded. So please subscribe to that YouTube channel so that you get information on in time if the moment it has been uploaded. And you may also circulate that link amongst your friends. So those who could not attend it, at least they can take advantage of these recordings, because only for that purpose that those who miss the entire session and those who could not pay attention throughout the session, if they wanted to get additional input, the recording will help them to get the additional input. That is the purpose for which the huge efforts of my team is underway. And if you derive benefit, if you inform and share this link with all of your friends, probably the purpose of the huge efforts which my team is doing, that will get recognized, that will get utilized for the benefit of the peer professionals. With this note, a 4th wave of COVID is at some of the in some of the part of the country is giving heavy knock at our door. In some parts of the country is a lesser lighter knock. But whatever is, we have to apply all COVID appropriate behavioral protocol so that we can mitigate with the challenges which again the 4th wave is telling all of us. And that's how I keep saying that follow all COVID appropriate behavior and protocols. And if you do not need to go outside your home, do not go. And that's how we keep saying, वक्त नाजुक है, संभल संभल के रहिए. वक्त नाजुक है, संभल संभल के रहिए. जब तक न हो बहुत जरूरी, घर के बाहर ना निकलिए. And keep learning despite all adversaries, despite all disruptions in and around us. Keep sharing information of these webinars amongst your friends and stay safe, stay healthy, and keep learning, because the moment you disrupt your learning, negativity will keep on coming. Thank you so much. Wish you all the best. God bless you all.
Thank you, sir. Thank you for inspiring us always with your words. I would now like to welcome amongst us our expert speaker for today's session, Professor Manohar Lal, sir, with an e-bouquet.
Thank you, Dr. Ayush Chopra. My
Thank you, sir.
sharing is disabled. Thank you. Sharing is disabled. Please.
Sir, it will be given to
It
you
is
now
not
after
working.
this bouquet.
It is
will
not
be given-
allowing me to share.
Sir, the rights will be shared to you now. You may check.
सर वो
All the time I feel-
बुके शेयर कर रहे थे ना, एट ए टाइम एक ही शेयर कर सकते हैं, तो इन्होंने
Yeah,
आपके
yeah.
पहले बुके शेयर कर दिया.
Professor Manohar Lal sir has teaching and research experience of more than 48 years, having taught at various universities including University of Delhi, JNU and South Asian University. He has served as the Director, School of Computer and Information Sciences, Indira Gandhi National Open University, New Delhi. He has also been the Professor and Head of Computer Science Department and Director, Computer Center at MD University, Rohtak and at HP University, Shimla, a product of IIT Kanpur, IIT Delhi, and University of Delhi. He completed his MTech in Computer Science and Engineering from IIT Kanpur and pursued his second PhD in Computer Science and Engineering from IIT Delhi. Earlier, he completed his master's and PhD programs in mathematics from University of Delhi. During 1982 to 83, he visited North Carolina State University for postdoctoral work. He has delivered more than 600 hours of lectures through educational channels, including EduSet and Gyan Darshan of TV and Gyanvani of radio. Professor Lal Sir has long research experience also. Earlier, he worked in the area of error correcting codes. Currently, he is working in the areas of theoretical computer science, formal methods in software engineering, and automation of reasoning. He is a member of a number of national and international academic and professional bodies. He is a reviewer for a number of national and international journals in mathematics, artificial intelligence, and e-learning. We are honored to have you amongst us, sir. I welcome you for this session. I now request you to please enlighten the House. Please, sir.
Thank you, please. I feel honored. Thank you very much for introducing me so profusely. I am very much thankful to Professor Hoda, my friend, Professor Subramaniam, and yourself and other panelists for giving me this opportunity of interacting with the scholars across the country and even abroad. I'm also thankful to the various institutions which are involved in organizing this lecture, like Bharatiya Vidyapeeth, Computer Society of India, and IEEE. I'm very much thankful to all the participants who have spared their valuable time for talking to us. Also, I'm thankful to my granddaughter Sarvakia, who is helping me in starting with the lecture. So with this, I start my lecture. But before starting the lecture, I may say a few points about my style of delivering lecture. So first of all, because of the lack of eye-to-eye contact, I have written down completely the lecture requiring little explanation. Secondly, because the topic is very, very vast, therefore I have to select some of the areas which are dear to me or by chance these happen to me. So with this formal introduction, I start with my lecture. Friends, the title, as you can see, is E-Science and E-Research, Practices and Potentials for Carrying Out Science and Research in Digital Age. The topics which we will be discussing under it, number one, E-Science, what it is. Second, E-Science, how it is conducted. And because in this explanation, cyberspace will be also involved, so we'll go into the details of cyberspace, how it developed, and what is the state of art of cyberspace. Third part is types and approaches to e-sciences and e-research, which are new to conducting science and research. Fourth part is distinguishing features of e-science and e-research and expected developments in the near future. And finally, conclusion and references. Friends, the part one, e-science, involves a lot of things, as you can see in this picture: supercomputing, digital humanities, computational humanities, big data, etc., etc. Some of which are great computing, some of which we will be discussing in some details in this talk. Friends, in the very beginning, we pay homage to the father of fourth paradigm of research. We'll explain what is meant by fourth paradigm in a little while. James Cray, who was an American computer scientist. He was born in 1944. He received the Turing Award in 1998. I hope everybody, all of us know that Turing Award is the Nobel Prize for computer science. On January 28, 2007, Cray, an experienced sailor, failed to return from a short solo trip to scatter his mother's ashes at Farallon Islands near San Francisco, and he was declared dead in absentia in 2012. James Cray, we pay our homage to. In honor of James Cray, Microsoft has instituted an award. Recipients are selected for their groundbreaking fundamental contribution to the field of e-science. And some of these, which are given below, are the recipients in the past. Friends, in honor of and in gratitude to legendary Jim Cray, father of the fourth paradigm of science. Next two slides are copied without any change from his lecture, which was delivered on January 11, 2007, which was his last lecture before his disappearance. Science, a transformed scientific method. Friends, most of the lecture has this basis, but because since 2007, a lot of developments have taken place in technology and therefore will incorporate those. But the foundation of today's lecture is the Jim Cray's last lecture delivered on 11th of January 2007. So what Jim Cray says about e-science. What is e-science? First of all, synthesis of information technology and science. That is, it is homogeneous amalgamation of science and information technology. We'll go into the details of this. Each of these lines will be discussed in details. Science methods are evolving. A lot of new tools are coming up every day in conducting science, and research also will discuss all those in details. Science is being codified and objectified. What does this mean? Objectified is almost what is meant by object-oriented approach. We'll discuss that is science is also being modeled according to object-oriented approach. How to represent scientific information and knowledge is computer. One of the approaches is objectification or object-oriented approach. Science phases that are delusions. Within about 5 minutes or 5 slides, you will see how data deluge is there because of the scientific investigations. How to manage this data deluge. These are some of the problems. Then scientific communication is changing. Friends, earlier reviewed, published work through the journals. Now there are a lot of other means also of communicating of our researches. So the next slide is very important. James says that science is evolving. The paradigms are evolving. Thousands of years back, science was merely empirical. That is, experimental it was there, as was conducted by Aristotle, Archimedes, and other scholars of the past, and even Indian scholars like Aryabhatta and Kerala School of Mathematics. So it was mostly experiments. Then around 1500 or so, the theoretical branch emerged. It was in the Western world, maybe Kepler was the first one who found from the Brahe's very enormous data, the rules of astronomical bodies movement. So that may be said as the first theoretical result was Kepler's, and later on it was applied by in the Western world by Galileo, and later on by Newton and others also, and in India in Kerala School and all others. Now the last about 4 or 5 decades, two new paradigms have come, which we call third paradigm and fourth paradigm. The third paradigm is computational branch simulating complex phenomena. That is, these are complex phenomena for which the closed form formulae like S is equal to ut plus half at square cannot be found. And therefore, we have to simulate the phenomena in order to get knowledge out of that. And last but not the least important is the current or fourth paradigm based on data-intensive computing. Within 2 or 3 slides, we see how much huge amount of data is being generated through scientific investigations. So the fourth paradigm, which is generated or which was proposed by Jim Gray, is this one, that it unifies all the 3 above: theory, experiment, simulation, and exploits massive data. Data may be captured by instruments or generated by simulators, processed by software, information and knowledge stored in computer, and scientists analyze database files using data management systems. So friends, these two slides were taken from Jim Cray with gratitude. Now, accordingly, e-science is pursuit of science using third and fourth paradigms. Before going into more details, some examples illustrate e-science and e-research. We'll give some of the examples through which e-science and e-research is being conducted. Huge data is generated. Friends, here the data amount is so large that millions of floppy disk or disk may be required to store that. Peta, exa, and tera, which are in the second line, are very important. That is the amount of data being generated. Tera is 2 raised to the power 40 of bytes, and so on. The first one. This is a project which is one of the most important e-science project, which is called Higgs Boson. Sends quest to discover elusive core particle cell. Organization, this is a name which is in France, and it is a European organization for nuclear research. It was established in 1954 and is based in Geneva in Switzerland. Has 23 member states, with Israel being the only non-European full member. Operates the largest particle physics laboratory in the world. In 2016, CERN generated 49 petabytes of data. Friends, you can imagine what is a petabyte. Storing 1 petabyte requires over 745 million floppy disks or 1.5 million CD-ROM disks. So friends, you can see yearly amount of data generated by a single project cell requires more than 100 million CD-ROMs. Second project, which is going on at massive scale, generating massive data, is astronomy pan stars. Enormous survey telescope located in Hawaii, USA, consisting of astronomical, I'll just suggest one, astronomical cameras, telescopes, and a computing facility for surveying the sky or for moving variable objects on a continual basis. It is to investigate the space. It is producing accurate astronomy and photometry of already detected objects. The entire sky can be surveyed 4 times a month. Each image taken by this project requires 2 gigabytes of storage, and the exposure time will be 30 to 60 minutes. Since images are taken on a continuous basis, about 10 terabytes, which I told you, 10 days to about 12 bytes of data are required by pen stars every night. You can see how much amount of data is being generated. In January 2019, pen stars data release was announced at 1.6 petabytes. It is the largest volume of astronomical data ever released. This is a second project. Friends, through this, following discovery, many discoveries have made, and these are 2 of the discoveries which have been made through this project. Penn Star discovers 2 supernova. I hope you know supernova, which are the burning or almost dying stars. And on the right hand, we have another illustration in 2017. Astronomers discovered an object in the solar system which seemed to be out of place. Most of the bodies in the solar system have elliptic, but it has hyperbolic motion. In third project, Square Kilometer Array is an intergovernmental radio telescope to detect radio waves project being planned and built in Australia and South Africa. And what it contains in 1 kilometer area, these are instruments which cover 1 kilometer area to detect radio waves. The project was conceived in 1990 and further developed and designed during the 2020. When completed sometime in 2020, it will have a total collecting area of approximately 1K. That is, the instruments will cover 1 kilometer area. It will operate over a wide range of frequencies and its size will make it 50 times more sensitive than any other radio instrument. It will require very high performance central computing engines and long haul links with a capacity greater than the total global internet traffic as of 2000. You can see how much data and how much computing power is required for these. If built as planned, it should be able to survey the sky more than 10,000 times faster than ever before. So, friends, we have seen three projects. The purpose of the last project to answer some of the fundamental questions of physics about the universe. To study the universe, astronomers use the entire electromagnetic spectrum as different wavelengths of light often reveal different astronomical objects. Optical astronomy is great for studying stars and galaxies that emit a lot of visible light. Infrared telescopes may be used to study cold, dust, and relatively cool stars. Ultraviolet telescopes can identify hottest and most energetic stars. Radio waves can travel unimpeded. What is the importance of this project to detect radio waves? Or is that radio waves can travel unimpeded by our galaxy dust? It is not impeded. Hence, can be helpful in detecting distant galaxies where hydrogen, a key building block of so many extraterrestrial objects, emits radio waves. Another puzzle. Though every part of the electromagnetic spectrum tells us something about physics that is going on out there, yet by using radio waves, the ability to observe the transition of neural hydrogen gas through galaxies can provide an interesting history of the whole universe. In summary, with this project, it is hoped to be able to answer big questions such as how were the first black holes formed? The second question, which is expected to be answered by this project, is was Einstein right about gravity? Third question, which we expect to be answered, is how do magnetic stabilize galaxies? And are we alone or there are other intelligent bodies also? These are some of the questions which are expected to be answered by this project. Friends, this project is expected to generate 5 zettabyte, which is a very, very big amount, which requires crores and crores of floppy disk and hard disks of data every year. Whereas global internet traffic in whole of 2016 was around only 1 zettabyte. And the required massive computational power is to be supplied by the world's most powerful computer summit. So, friends, these were some of the projects which are going on. Now we discuss in detail what is e-science and how it is conducted. Friends, the discussion so far, including the example, justify the following Wikipedia definition. What is the definition? The definition of e-science as, sorry, please, is computationally intensive science, that is third paradigm, that is carried out in highly distributed network environments, or science that uses immense data, which we have seen is being generated by some of the projects that require grid computing. The term sometimes includes technologies that enable distributed collaborations, such as access grid. Friends, access grid is something which is very advanced video conferencing mechanism. Access grid is a collaboration of resources and technologies that enable large format audio and video based collaboration between groups of people in different locations. It includes multimedia, large format displays, presentation, and interactive environments. In simple terms, it is advanced video conferencing using big displays as are shown on the right-hand bottom with multiple simultaneous camera feeds at this one. So access grid may become sort of technology which may be available to us also in near future. Friends, second part, how e-science is conducted and what is cyberspace. We'll discuss in detail. The term e-science was created by Johann Taylor in 1990. And the discussion so far is for theoretically what science is. However, if we examine the process by which e-science is conducted, a number of new facts are revealed about it. Friends, this is most important slide for our purpose. One of the most important slides. What is e-science? If we go into the processes, e-science is about mapping intellectual assets like theories, laws, etc., including representation of entities of the natural or social space to cyberspace. Once again, e-science is about mapping all these intellectual assets of the natural cyber social space to cyberspace. And why we do it? To get higher intellectual, practical, tangible values of the assets. For example, when massive data is there, computer is used to extract knowledge or even principles, which may be even a few. Now that is the higher value. So friends, for our purpose and otherwise also, e-science is about mapping intellectual assets of the natural or social space to cyberspace so that from the cyberspace we get higher value. And not only that, e-science is also about how to map it back so that we can get the effect. I read the last line and then mapping back through human actions and or cyber mechanical actuators to natural or social space for verifying results in or for bringing desired changes to the natural or social space. Why we do it once again? We map to the cyberspace the various phenomena and entities of the natural and social space, and we map it to the cyberspace because from there we get higher value, like getting knowledge from massive data. And then we use that knowledge to effect the changes, the desired changes in the physical or social space. So this is the essence of e-science. Friends, in order to understand better, we need to briefly discuss cyberspace or evolution of cyberspace. Friends, cyberspace, what is cyberspace? At the top level consists of bare minimum with gradually reduced and more miniaturized hardware. A portion of hardware is gradually reducing and required computing and communication and sensors, and very large with ever increasing share of software consisting of a number of integrated systems of such. Cyberspace is gradually becoming dual space. What by dual space I mean is that everything in the physical and social space is being mapped truthfully in the cyberspace. That is, we have an image of everything, or we hope to have image of everything in the cyberspace of the physical and social space. So friends, we go in little bit more detail of what is cyberspace, how it was initiated. In the beginning, friends, cyberspace consisted just of isolated computer systems like this one. I go back into the history of this one. Earliest computers up to at least 1983 were stand-alone computers. Historically, computational physics was the first application of modern computers in science, where computational physics is the study and implementation of numerical analysis to solve problems in physics for which methods and theories already exist. Thus, before 1983, cyberspace consisted of stand-alone computers. On the left hand, you have two images of the first computers, almost the first computer Colossus, which was designed and completed in 1940, and the bottom is. And friends, I don't know whether you know or even Professor Hoda might have seen or not, but I have seen that the output was on the paper tapes as is visible in the bottom diagram on the left hand side. So that was the total cyberspace in which the computers or were isolated machines. Friends, then the second stage came. In the evolution of started with the introduction of internet and World Wide Web. January 1, 1983 is considered as the official birth date of the internet. Prior to this, the various computer systems were not connected. Friends, what is internet? Though all of us know it, but just for the sake of introduction. The internet is a sort of information highway system of roads, bridges, and tunnels. It is a technical network and infrastructure that connects all the computers and devices that are online. Being connected to the internet means devices and whoever is using them can communicate with each other. So friends, second stage of cyberspace started from 1983, but not much. The real revolution in connection of computer systems came around 1990s. Tim Berners-Lee. Since the middle of 20th century, with the introduction of electronic stored computer mainframes in 1940s, internet starting in 1983. But in actuality, the introduction of the web by Sir Tim Berners-Lee in 1990s, cyberspace started developing. Cyberspace now means space consists of electronically, optically represented data information, and which is hugely connected. So it is the World Wide Web around 1990s, which actually made us wholly connected and the world became a global village. The evolution of World Wide Web actually has a longer history. World Wide Web is said to have originated with the idea of memex, proposed by Werner Bush in 1945 article, as we may think, as hypothesis, etc. So the idea was Werner Bush in 1945. With the introduction of World Wide Web, various social media tools, including Twitter, Facebook, blogs, LinkedIn, etc., developed, which are useful for communication of scientific purposes and otherwise for social interaction also. So, friends, we can say that around 1990, the scientific applications became feasible through the World Wide Web or the internet. Stage 3 is very interesting. The evolution of cyberspace, which is currently ongoing and may be called sensorization stage. Friends, so far as the sensors were not playing much role except in astronomical investigations. Now, for the last about 15 to 20 years, sensors are playing a very big role. In this respect, developments are only in rudimentary stage. The basic difference will be that strong sensors will be ubiquitously, that is, they will be universally employed so as to capture moment to moment information about every entity, at least on Earth. For example, in respect of your refrigerator at home, you being anywhere outside can know its content, parameters of its safety, etc. Similarly, light, if not required in your home, may be switched off automatically from a distance. In the same way, for anything, say about a ship at sea, data about it will be available to the concerned through the sense. The internet, World Wide Web, computing, communication, devices, etc., make an enormous cyberspace. The cyberspace initially became a means for providing instant across the world the required data, information, knowledge, and services. However, through its day-to-day enrichment, both intensively and extensively, the cyberspace is extending its reach in representing electronically and optically the entities and phenomena, first of the natural and artificial world through CPS, and then through the social world through CPS, as next we discussed. Friends, in the very beginning, the cyberspace consists of that somebody fed the information. It is Web 1.0, and we could only read. The second part is that even the users could write the information and could read also. This is, however, reading and writing with this started the Web 2.0, which plays a very important role in scientific investigations. Friends, the second phase. Here, please note on the right hand side physical space and sensors. Now, no human is required to read information is also. Human beings also can information, can read information, but this new development is that from there are a lot of sensors employed in the physical space, and the data is being automatically sent through the space. So this is the one of the new developments through the sensors. Friends, in this, every entity and phenomena from the non-human physical world, including man-made artificial, is intended to have its cyber dual through the senses. Cyber dual of a tree, merely the identifier, tree number, tree type, geographical location, but also includes its physiological processes, its safety and health parameters. Similarly, a ship is not merely represented by its identifier or by its dynamically changing geographical location, but also by movements of the people and goods within the ship and various processes about their safety. For each physical entity, the authenticity of its representation is dynamically maintained through sensors. So sensors now in the new revolution of cyberspace development is playing a very important role. Friends, now another development is happening. In the previous slide, you saw through the sensors the information about the non-living entities, or that is from the physical space, are being fed to the cyberspace. It was unidirectional. But the new stage is happening that even when the actuators are there, human beings sense through the cyberspace that a ship is at risk. And then they try to protect the ship through the actuators. So this is the later development is that not only the information is about the physical world is being fed to the cyberspace through the sensors, but corrective actions are also possible in which either the systems within the cyberspace or the human beings who are monitoring the data, they find something needs their help. They initiate action through the actuators to prevent the possible damage. So this is another next development in the cyberspace which is taking place. Friends, the latest one of the possible many applications I'm giving here is that this elderly lady is being watched or monitored through by a robot using the CPSS, the technology which I did, that is the sensors and actuators. That is, the sensors provide to the specialist the health parameters of this old lady, and the system or the concerned doctors then take appropriate action through the actuators. And this is what is there in Internet of Things, what sensor-based technologies is doing. That is, you can see one of the blood parameters, blood pressure measures of the lady is being taken and continuously being sent to the concerned person. Similarly, many other things, various parameters are delivered to the experts about this lady, and then they propose. For example, smart pill box is there on the right bottom, and they propose that this particular medicine should be taken by this lady, and automatically the actuators deliver that pill to the concerned lady. So this is some of the scenarios of the latest developments in cyberspace, in which the sensors and actuators are playing a very significant role, not only in healthcare, but in scientific investigations also. Friends, this is actually the upward me, that is here, the sensors, actuators, and this is another stage. This is the final stage which is not yet realized. That here, not only the parameters of single individuals is being monitored, but the interactions, social interactions between the individuals are also possible to be monitored through the system, though the technology is still under development. That is, the whatever are the social interactions between the individuals, those are also possibly representable in cyberspace. And as a conclusion of that, the actions may be taken as is shown in the next slide. Friends, on the left hand, it is the old one, which is not social. Only the monitoring is done by the cars, and the cars adjust their speeds accordingly. But on the right hand, a number of individuals are interacting, and their interactions are also monitored, and based upon the interactions among the human beings, now the remedial measures may be taken. So it is that is in this stage which will be developed in future, the social interactions between the human beings are also monitored and represented in the cyberspace. So this is of the near future, friends. Now we'll discuss various types and approaches in cyberspace. Friends, again, we gratefully borrow from Jim Cray. And I'll explain. Jim Cray says, for example, for every science X may be physics or chemistry, two more disciplines or e-sciences have developed. For example, of physics, we have computational physics and physics informatics. Similarly, for biology, we have computational biology and biological informatics. I give in details what is the purpose of this one, and these developments have already taken since 2007, that all the data is fed to the cyber system. And then the problems in the form of questions are asked from the cyber system, and the answers come from the cyber system. So in this section, we'll discuss in detail the new types of methodologies which have become possible because of the information revolution for each scientific discipline. Hence, apart from specific new scientific disciplines, including those of interdisciplinary, transdisciplinary, multidisciplinary categories, emerging out since the advent of IT revolution, the following disciplinary developments are generic in nature. Generic means for each science. We have a computational X, X informatics, and digital X. We'll discuss in detail. These are actually not new sciences, we should mind. Rather, each of these is a new approach to pursue science X. X may be physics, chemistry, etc. Using computer as a medium, these are new approaches to pursue science X using computer as a medium. Each of the prefix, suffix, or term, computational informatics disease, is only connotational and not definitional in the sense they don't have definite meanings. Computational X1 and computational X2 may bear quite different relation to the respective sciences X and X2. What I mean to say, the meaning may change of computation with respect to physics and chemistry. Anyway, examples of these types, we must have heard all these terms: computational physics, computational chemistry, computational biology, etc. We have already heard and we know about bioinformatics, geoinformatics, nursing informatics. Similarly, we had a lecture also on digital humanities, digital sociology, digital electronics, and digital signal processing. Digital is used as a prefix not only for academic disciplines, but in other contexts also, for example, socio-economic phenomena, digital culture, digital economy. Please differentiate between economy and economics. Digital economy is a social phenomenon. Digital economics is an academic discipline. So, digital is used for socio-economic phenomena also in addition to academic disciplines. Friends, we distinguish between the three terms. Using the example of money and sociology, how digital computation and informatics differ from each other. Example of money to differentiate between the terms digital computation and informatics. The money available through the electronic wallet, PIN, is digital money. Why? Because it cannot be touched or cannot be transferred physically. Only electronically this money can be transferred, it cannot be touched, and therefore it is called digital money, or whatever money is within the soul. The processes that go inside, this doesn't happen when you transfer a money, say, of 1,000 rupees to a friend. It doesn't happen open automatically. Some processes within the computer systems are going on. And those processes which transfer 1,000 rupees to your friend's account constitute what is called computational aspect of IT. The large number of accounts that control, keep record of these money is called informatics. That is, when you have in your account 10,000 rupees and you want to withdraw 12,000 rupees, it is denied. That is, there are already records within the computer system of each money's available money and all that. And those records constitute what is called informatics. I hope you might have had some feeling of distinction between the terms. Next, we come to distinguish these three terms through an academic discipline. Digital sociology is a subdiscipline of the academic field of sociology. It focuses on understanding the use of music in sociological phenomena of the use of digital media, how the digital media is changing the social behavior is the subject matter of digital sociology. Computational sociology, in order to use the computer systems to analyze the sociological phenomena, that branch is called computational sociology. Using computer simulations, artificial intelligence, complex, etc., constitute world to the computational world. In order to get higher and back to the natural between the type of cyber assets basic that name of that. And then that mathematical model is converted to computational model. So friends, the computational science, for example, chemistry, computer science, and applied physics. So computer science, computational science is at the intersection of these three. I take an example of computational chemistry. Is a branch of chemistry that uses computer simulation. Please note the word simulation. And I told you, simulation is used through the massive, don't know the closed equations like scale. That is really the phenomena and then apply computer systems and get some knowledge of that. Computational chemistry is a branch of chemistry that uses computer simulation to assist us in solving complex chemical problems. It uses efficient computer programs based on methods such as ab initio or density functional DFT of theoretical chemistry. So friends, for a computational physics or computational chemistry, there must be sound theory. If there is no sound theory for a particular science, computational X cannot be applied to that. A prerequisite for computational science or computational chemistry or computational physics is that computational chemistry, there must be a theory of chemistry which is sound, similarly for physics or biology. So for computational X to be effective, a sound theory is essential. Otherwise, you can't have computational X if X does not have a sound theory. Friends, the next is computational biology. And friends, I don't know, you may be surprised that computational biology is the earliest computational aspect and of sciences, and it was proposed by the great Turing, father of modern computer science. Let us read whole of this, and this is the monograph on the right hand side, which was published in 1952. Computational biology, a branch of biology involving application of computers and computer science to understanding and modeling of the structure and processes of life. It entails the use of computational methods for representation and simulation of biological systems, as well as the representation of experimental data, often on a very large scale. The last lines are very important. The beginnings of computational biology essentially date to the origins of the computers. Alan Turing, called the father of computing, used early computers to implement a model of biological morphogenesis. Actually, it was Turing who gave the initial ideas of computational biology long back in 1950. Challenges for computer science. Friends, you know, every transformation or development of a tool is not just a easy pass. It has challenges. We enumerate some. And this is very important. As mentioned in the previous slide, computational science is about mapping the relevant real world to the cyber world. Please note the real world to the cyber world. But the real world requires real numbers for its proper mathematical model. These two lines are very important for us. But the real world requires real numbers for its proper mathematical model. On the other hand, cyberspace is purely digital. That is, a number is represented only by a finite sequence of binary numbers. For example, E or even 1 by 3 cannot be exactly represented. Pi can't be represented. Even 1 by 7 may not be representable exactly. And this not being able to represent exactly has created very serious problems and continue to be a very serious problem. And this is one of the biggest challenges for computational sciences. What I say, the real life generates real numbers. Computer can represent only digital or finite sequence of binary digits, which are not necessarily always real numbers only. They may be rough approximate representation, and these approximations sometimes lead to serious damages, as we'll see in the next two slides. Only because real number cannot be represented exactly in the computer system. And again, I borrow this slide from the great Jim. The answer is 42. But what we mean by this, is it 42.5 or not, etc. I explain it more details, what Jim Gray intends to say. Friends, these two disasters occurred because of not being able to represent real numbers exactly. On February 25, during the Gulf War, the Scud struck an American army barracks and killed its own 28 soldiers. American bombers killed their own soldiers. The cause of failure to be discussed was only more minor oversight in representing the numbers exactly. Another one. Similarly, on June 4, 1996, an unmanned rocket, and again it failed. It took 1 decade to develop and cost $7 billion at that time. And the cause, as I mentioned, was either due to neglect or due to inability to represent real numbers exactly in the computer systems. Friends, the difference is something like this. For example, the Mars is this much, 22,057, etc., 3342 kilometers. But either by mistake or because of the limitations of the computer systems, the two least significant bits, 4 and 2, were neglected. But though it is a very minor distance, when it is implemented, it is applied millions of times in computer calculations, it leads to huge gap in the intended point and the actual point of landing. So friends, one of the major challenges of computational sciences is the real representation in the computer system. This is only one of the challenges. Don't think that these are the only challenges. Now we have already discussed computational. Now we'll discuss informatics. In academic context, informatics has a number of connotations. We consider just two. The term informatics is used in for the discipline which is called computer science in USA and other places. Please, in Europe, they don't call it computer science. They call it computer informatics. And there is very much reason, because computer science gives a wrong impression. The reason probably is that the term computer science gives the impression that it is science of computer. Computer science, science of computer, which is not. As one of the pioneers of the field, Dicaster says, the relation of computer to computer science is the same as the relation of telescope to astronomy. Computer is just merely a tool. It is not subject matter of study of computer science. It is merely a tool. Informatics. It is the fourth paradigm where the huge data, as we have seen from the earlier three instances, how here we use informatics in the sense of data science, or the fourth paradigm of Jim Cray is concerned with extracting knowledge and insights from the noisy, unstructured, generally voluminous data, as we have seen in the three projects. How to get knowledge? I've said that computer is used to get higher values. Higher value means from the very large volume of noisy, unstructured data to get knowledge which can be used in taking actions. Use methods and computational tools, applies extracted knowledge, etc. So the basic purpose of informatics is to extract knowledge which can be used in taking corrective actions. So that is the goal, and this is the fourth paradigm of both computational X and X informatics. Use computer-based resources to achieve intended goals. Or you have to adjust. But there are main differences. What is computational X and informatics X? As I mentioned, friends, for computational X, there must be a sound model, sound theory in order to get computational X. The already available theoretical assets, including theories, laws, etc., and mathematical models of X form the basis of computational X. These theoretical assets are used for developing computational models, and then based on these models, either software is developed or already developed software tools are developed. And then these software tools are used to solve problems related to science X. So here, in computational X, a sound theory must exist, out of which we can make models, out of which we can develop softwares, so that we can solve the problems. In informatics X, these are not the issues. In informatics, the immediate concern is not solving problems, but extracting knowledge and insights from noisy, structured, and unstructured, jelly, voluminous data. Extracted knowledge is then used in solving problems. So you can see the concerns are different in computational X or informatics X. Friends, as for natural sciences, I am telling you that informatics is more useful in social sciences, and of course it is used in natural sciences also, but these are more useful in social sciences as compared to natural sciences. It is comparative. Otherwise, it is quite used in natural sciences also. What is the reason? As for natural sciences, laws are well defined and succinct. S is equal to ut plus half at square. Data is generally well structured. Therefore, extracting knowledge may not be a serious concern. However, informatics is the major concern for biosciences and social sciences, because they don't have that well-defined closed formulae like E is equal to mc square, E is equal to mc square, embeds lot of knowledge just in 3 or 4 characters. But that type of small or closed formulae are not available in social sciences and biosciences. Therefore, it is more useful there, because there the concern is how to get knowledge out of massive data. Different connotations of informatics. Friends, informatics have many connotations. I discuss here just two. Please don't mind it. this is creating some problems. Okay. Bioinformatics is, please note the difference. I am explaining it bioinformatics and social informatics. In these two, the informatics plays quite different roles. Bioinformatics is interdisciplinary field that combines biology, computer science, mathematics, etc. to develop methods and software tools for understanding biology, analyze and interpret biology. In the above, you can subject of studies biology. Informatics is used as a tool. But in the following, subject of studies information technology and social provides the context. Please try to understand the difference is very subtle. In the earlier one, bioinformatics subject of studies biology. In the following subject of studies information technology. Anyway, I hope you understand these two meanings are quite different in social informatics and bioinformatics. Anyway, challenge for informatics. Again, as I've told you, it is not a straightforward matter to get computational science. Similarly, it is not a straightforward matter to get X informatics. Friends, in some of the previous lectures, including one on the mathematical models and imperfect knowledge, we discussed how to use natural language, common sense, and single term of multiple meanings lead to information of knowledge, where imperfect knowledge may be uncertain, incomplete, vague, imprecise, etc. And friends, this imperfect knowledge is a serious problem for designing X informatics, where X is a science. We illustrate it through some examples. Friends, this example is, please look at the example. I have told the word period has many meanings depending upon context. Therefore, the meaning of period is not definite. As you already know, in chemistry, period is in the periodic table as a single row. In physics, you can see on the left, a graph is there. Period T is time required for one and complete. So the meaning of period in chemistry and physics is different. The meaning of period in astronomy is still different. Meaning of period in mathematics is still different. Meaning of period in music, a unit of melodic organization made up of two balanced phrases, is quite different. In history, period in study of history, culture, literature, the early medieval period. This meaning of period is different from all the earlier meaning, and we know human and animal physiology period occurs. So what I intended to say, that even a single word has many, many meanings, that the meaning is ambiguous, and only the context may resolve it. And one of the goals of informatics is to integrate new knowledge in the earlier knowledge base. Now, integration is not simple because it requires a lot of context, whether the period is from chemistry or physics or astronomy, etc. And resolving this context may be a very difficult task. And therefore, this is one of the biggest challenges for informatics. Friends, now I have already discussed computational X, I have discussed informatics and digital. Digital is used one in sciences where it is different from continuous, as you know. The another use is that of in social sciences. For example, digital age is not that of negative of continuous age. No, it is something different. It is the age through which we are passing, in which ICT is dominating feature. So in social sciences, digital has different meaning. It is not opposite of continuous. And in academic disciplines, digital humanities and digital social sciences. So friends, digital has two connotation, one opposite of continuous and the other is in which the current ICT is dominant. Digital has some other connotations also. We being computer academicians and particularly scientists, we should know this also. This is digital physics is neither of the earlier two. It is a speculative idea and what is that speculative idea that the universe can be conceived of as a vast physical computational device or as the output of it. That is, the world is a computational device. This is one of the ideas. Many people don't agree with this idea. They don't agree even the man's brain is computational. Anyway, we don't go into the niceties of this, but what I want to tell that digital is used in many ways. Now, friends, we come to distinguishing features of e-science and e-research and expected development in the near future. Social media is the first, which is new development for doing sciences and research. I'll explain it. Social media, consisting of Twitter, Facebook, blog, LinkedIn, ResearchGate, Instagram, Reddit, etc., is an efficient way for scientists to connect with public at large. Social media, though I'm using it is a plural, but I'm using it in singular, is a tool that can reach millions of people with important information. So, new developments or the tool of e-science or e-research, in which E is for the ICT age, these social media tools for doing and communicating research, science and research. Now then there are another academic social networks are similar to social network sites but designed for academic community. These online platforms allow us to develop a profile and connect with other researchers. And number two, share academic related content. They are user friendly for presenting our research articles and other scholarly outputs to our colleagues and scholarly communities. So friends, the first tool of e-science, which is different from science or conventional science, is social media. Some well-known social media sites are ResearchGate, Academia Edu, and Mendeley. Each of the above allows a researcher to create a profile, share papers, engage in discussion, and find collaborators. Data intelligence, second leg of e-science, which differentiates it from the conventional science. As we have mentioned earlier through Jim Gray, also that data intensive computing, and we have seen a number of examples, is a class of parallel computing applications which use data parallel approach to process large volume of typical info. The other type of computing which is so far dominant devote most of their execution time to computation requirement, compute intensive. Now it is data intensive. Compute intensive was before the, you can say 1990s or even 2000s, where major resources of the computer were devoted to computational aspect. Now, the major requirement is how to handle massive volume of data, how to get knowledge out of it, how to use that knowledge. So, friends, the fourth paradigm is, or the second leg of e-science and e-research is data-intensive computer. And some well-known models for data-intensive computing in which data plays major role. MapReduce architecture and programming model by Google. Then Apache Hadoop, I think you must have heard of, is an open source software project sponsored by Apache Software, which implements this one. That is, Apache Hadoop's architecture is based on data intensive computing and not computing. Then HPCC is another one, was developed and implemented by this one. The development of this computing platform began in 1999 and applications were in production by late 2000. HPCC approach also utilized commodity clusters of any way I'll explain, where a commodity cluster is a computing system comprising an integrated set of systems so that each subsystem is capable of independent and complete operations. So HPCC contains thousands of connected computer systems in which each can work independently and completely. So friends, these are the three models or implementations of data intensive computing. And friends, I've told you the first leg of e-science is social media. Second leg of e-science is data intensive computing. E-research. We have not discussed e-research specifically, though of course, whatever was the discussion was relevant for e-research also. E-research is a form of scholarship conducted in Web 2.0 based networked environment. We have already seen a social CPSS and all that, in which the old lady is being treated automatically through the robot. So e-research is utilizing interface tools. It is research involving, this line is very important, that the modern tools allow collaborations among scholars separated by distance, often on a globe. This is a very important aspect of new research. Increasing computerization of research process, often involving high-speed experimentation with new data visualization. It is very important. Graphs, videos, images are also playing, not just the text only. Now, the last point is very important. Earlier, publication preservation, but now less formal and less institutional means are also there to communicate our research. Social networking sites, personal websites have emerged to communicate our research also. This is a new development of e-research. One major departure, please read it very carefully. I have to adjust this. Please bear with me. E-research. One major departure in e-research from conventional research is the goal of preserving not only all, please read it, very important it is. One major departure in research from conventional research is the goal of preserving not only all the data generated at any place at any time, but also all the processes, algorithms in execution as executed originally. That is everything. If I am conducting an experiment in my lab, that also must be copied in the cyberspace and preserved for all the generations to come in future. Not only the outcome of my research experiment, but the whole experiment should be copied in such a way that it can be repeated in future also. And all the experiments which are occurring in thousands and thousands of laboratories and big projects, all processes, I underline all processes, must also be copied so that those can be executed in future. This is the goal of e-research, which is not the goal, which was not the goal of it. Not only the data, please I emphasize, but the processes also must be copied so that those can be repeated. This is one of the goals of e-research. Friends, third leg of e-science is citizen science. This is the third phenomena which was not there in conventional science. Outsourcing science and research. Friends, you read these to actual happenings. In the deep jungle, a group of pygmies out for hunt stop and gather around the shattered remains of trees strewn across the jungle floor. One of the hunters pulls out a small GPS device and marks the spot. Thousands of miles away in an office at the University College of London, a researcher adds the coordinate to an online map of Congo already speckled with reported signs of illegal logging activity. Don't you see? It is citizen science. The pygmy group is uneducated. They are normal citizens, and not only even normal. However, they are collaborating with a research in London. Is it not citizen science? Another case across the Atlantic. A teenager plays a computer game, carefully manipulating the branch-like shapes of proteins, watching her score rise and fall as she optimizes their configuration. The girl is not much specialist of proteins, but she is experimenting with the already available software. Across town, researchers at the University of Washington harness her folding skills to identify proteins. The work is being done by the teenager, but analysis is done by the researchers. Again, is it not citizen science? The biggest advantage is that normal citizens may be involved in doing science. Friends, I give some pictures. You should also log into SciStarter. This is why I have not deleted it from the image. SciStarter is a website for prompting ordinary people to do or make contribution to scientific investigations. The girl at the top is contributing to learning how to test water quality. The elderly couple on the bottom right helping scientists to track bird migration. Friends, is it not citizen science? The children on the on the left top, helping scientists document plant species. Friends, notes, SciStarter is the website you should also sometimes expert. Similarly, the two ladies on the bottom right, they are monitoring air quality of their own area and they are uploading it to the cyberspace. Friends, tracking pollinator pollutions by young child and his mother. And on the right bottom, a young girl is helping scientists to correct data. And you say it is citizen science in which every citizen can contribute to scientific endeavor. And this is the last picture slide. So, friends, this is citizen science. How citizen science? We briefly define it. Citizen science in most generic sense refers to emerging practice of using digital technology to crowdsource information about natural phenomena. Citizen science is the name of scientific research projects that engage members of the public in some data-hungry fields like ornithology, which is methodological study and consequent knowledge of birds. Bird watchers upload data, and they are common people, not scientists. Phenology, the study of cyclic and seasonal natural phenomena. Ecology, about all these, anybody can contribute to scientific endeavors just by uploading data. Data-hungry fields like these rely on geographically distributed volunteerism because for birds, you don't require one particular, it should be in the South America also and in Africa also and in Siberia also. Then and only then you can have the true knowledge about the birds. And for that, you require ordinary citizens. Utilizing fairly simple, provided by well-designed websites, amateurs have helped. Amateurs, not specialists, have helped model complex protein structure, have helped in mapping the neural circuitry of mammalian retina, have helped in discovering new astronomical project. Astronomy is really the richest field for citizen science. Friends, I give some projects here, which are citizen science projects. Please, city. One of the earliest citizen science project, for instance, takes advantage of private citizens. That is here. They are not collecting data. They requested people to spare their computing resources for the people who can use the computer, but they don't have their own computational facility. So SETI was, in that sense, not data gathering, but computational facility sharing. The second is Amazon's Mechanical Atatürk is a crowdsourcing marketplace that makes it easier for individuals and businesses to outsource their processes and jobs to a distributed workforce who can perform these tasks virtually. This could include anything from conducting simple data validation and research to more subjective tasks like this. So this is another platform for citizen science. And this is Juniverse, which is the most popular citizen science platform. I have given the website address also. We should at least log once. Juniverse is a citizen science web portal owned and operated by citizen science. Kevin Schwanitsky and Chris Lindlord, both astrophysicists at the University of Oxford, started Galaxy Zoo, of which it is the advanced form, in 2007. It is home to some of the internet's largest, most popular, most successful citizen science projects. The Juniverse community consists of more than 2 million registered volunteers. I am also going to register. I request you also to register. Juniverse project, unlike SETI, require active participation of human volunteers to complete research tasks. Projects have been drawn from disciplines including astronomy, ecology, cell biology, humanities, and climate science. Really, you should experience it once. Well, friends, another feature of e-science and e-research is culture of global sharing. We have already talked, but this is a international space station program in which a large number of countries are involved in doing. So culture, I am emphasizing the culture of global sharing. This is another aspect. Similarly, Human Genome Project, lot of countries and people are involved in this. Culture of sharing, what I want. Polymath project is a new in mathematics, is a collaboration among mathematicians to solve important difficult problems. The project began in 2000, where the problems are and online solutions are there. Friends, time is, but I'll be finishing. Some scientific journals. There are thousands. However, we can find articles on e-science and e-research in the journal and multidisciplinary science journal like Nature and all these and scientific advances. And these are some of the journals in which we can find e-science and e-research projects. Not many slides are left. Of course, when we are talking a discussion, we must talk of the challenges and research domains. It was mentioned earlier, one of the goals of e-science is not only preserving all the data generated, but also preserving all the processes as executed earlier. The goal requires exponentially increasing because more and more processes are going on, are going to be. The goal requires exponentially increasing processing and computing power, speed, which not only are technologically formidable tasks, this is a very difficult task, formidable, but which also conflicts with the goal of green computing, because more the communicating and computing, it will conflict with the green. And in itself also technologically it is formidable. Another challenge as discussed earlier through example of period is assimilating new knowledge in the existing global knowledge. You can't put, when we eat a particular vitamin, if we are vitamin deficient, after 1 day or so, you can't trace where the vitamin, it is completely dissolved in the whole body. And that is required for the homogeneous knowledge base also. And for assimilating new knowledge into the old knowledge, it requires how to disambiguate the word period, like lot of such things. Almost every sentence involves so many ambiguity. This is another big challenge. This is, friends, I'm coming to the conclusion. This is not the conventional conclusion. It is a feeling of pain, agony also. So I am saying it in a different way. But we read it from the book. This is highly readable. Lord is one of the participants of universe or the originator of universe. What he writes. Science is, it has to be a human pursuit. When progress comes, it arrives not out of belief, but as the result of hopes and dreams, followed by blood, sweat, and not infrequently the tears of the normal human beings. Science comes out of the human aspirations, friends. What is more, this is as true of solo works by Newton, Darwin, and Einstein, because they were supported, because the people wanted that work to be done, as it is of the great collaborative projects, as I have talked of Large Hadron Collider or Human Genome Projects. This is true of both, which bring together thousands of people from hundreds of institutions to produce science on almost industrial basis. What is the essence of this code? That it is the human beings' aspirations, their feelings, their tears, everything because of which science develops. But, friends, you will allow me 1 minute to adjust this. Oh, sorry. The ICT revolution, this is very important from my point of view. The ICT revolution has made the world an effective global laboratory in which everyone having intellectual curiosity for search of truth. The feature, the intellectual curiosity is the feature which distinguishes human beings from the rest of the animal kingdom. The animals don't have intellectual curiosity for some purpose. I read it once again, though time is Lord. The ICT revolution has made the world an effective global laboratory in which everyone having intellectual curiosity for search of truth, the feature distinguishing human beings from the rest of the animal kingdom, can participate. Everyone having intellectual curiosity can participate. It is just a matter of channelizing our energies and attention on social media and idiot box, away from cheap and mischievous propaganda and stories invented every day to deviate attention from the reality and truth. This is not conclusion only, though it is conclusion because these are the last slides, but it is my agony also that despite technology allowing us to be scientists or have scientific temper, day by day, particularly for the last 20 and 30 years since the social media has come, social media is less being used for scientific work and more for spreading rumors and all that. We have become less scientific, less tolerant. The macho culture, like Putin's and others, is dominating. We are becoming less scientific, despite scientific opportunities are available there. So, friends, these are the conclusions. These are some of their, and this is a bit hard of hearing. I am so please, you may ask questions, etc. And please, any questions, please? Hello.
Yes, sir.
Please, any questions?
Thank you so much for giving
For
such a
the
detailed.
thank you for enlightening deliberation, sir. I am sure that this insight session would have enlightened participants about the real life application. So we have questions. Can you hear me, sir? Can
You
you
are
hear
audible.
me, sir?
Yeah.
Yes,
You
you are
should be
audible,
audible.
please.
Okay. So
Please ask
the
questions.
first question that we have is,
Dr. Ayush, I'd like to write down it also. Yes, please, question.
yes, sir. The first question I would like to. Okay, okay. So the first question is digitalization has changed the ideals and practice of science ethics.
Dr. Chopra, would you
Sir, the
repeat and
first
a bit
question.
slowly? Once again, please.
Okay, sir. The question is digitalization has
Your
changed
voice,
the ideals.
sorry, your voice has become slow, not audible. Just 1 minute, I'll take. Please. Madam, there is a problem on your end.
Sir, the first question I have is digitalization has changed the ideals and practice of science ethics. How large is this gap between practice and ideals?
Well, Doctor, it is really very, very good question. And, you know, that social phenomena and technological phenomena, they support each other. They are mutually, as I mentioned, that science is the aspiration of human beings. But as social beings, I don't say that we have become more unethical. I don't say it. The visible part is really noisy. But I think most of the people know the reality and all that. However, this is a very complex question involving all the social sciences, humanities, technological, and all that. It definitely, I appreciate the question very much, but no panacea is there for these things. Somehow, nature has its own way of doing. Sometimes the rationality has reached its peak during, say, 1960s or 80s and all that. And every cycle of rationality is followed by irrationality also. It has, if we go through the history, it has happened in the olden time, in Vedic times, or in the Greek classical time. It was really very rational period, and each was followed by completely irrational ones. Similarly, I feel the scientific revolution and technological revolution, which was at its peak during 60s and 1960s and 70s, when we fortunately were students also, a rationality, somehow technology is not able to answer many of the questions. And people get fed up with the rationality. And then the irrationality takes over. So according to me, I feel that these cycles are there. This phase of irrationality in which machoisms like Putin and others and Trump, I think it may subside. And again, but once it subsides, then the technology available will strengthen the rational approach to life and etc. So no definite answer how long this irrational thinking, unethical thinking may continue. But definitely I am hopeful that in the long run, technology and humanity will combine, or technology will enable the humanity in both ways, and we will have better times. But no, I'm not in a position to answer this question completely. This is my own opinion. Any other?
Okay, thank you, sir. Though it was a very justifying attempt to answer the question. Another, I would like to ask another question is how digital technology contribute improving scientific investigation?
Well, Doctor, as you see, we have already seen in my lecture that, for example, I take the example of citizen science. Now, it doesn't mean that the machoism is dominating throughout the world. No. I know thousands of young people who are devoting their time in citizen science. So, what I mean to say, technology is definitely improving the provisions for doing better and better scientific. And of course, the big projects like Cauldron and all that, they are investigating the fundamental questions. So technology is definitely helping improve science, and definitely number of new facts have been found through the technological improvement, particularly ICT. Yes.
I would now thank you, sir. I would now like to request Professor Huda, sir, to please present a certificate as a token of remembrance to you.
So thank you so much, sir. The topic which you had chosen will keep on changing because the ever-changing nature of the technology, ever-changing nature of the digital domain. So the attempts which you have done, as on date, that attempt is sufficient. While
That is,
that question.
uh,
But maybe a decade down the line, there could be a different answer.
it
So this
is.
will keep on happening. The beautiful part is around 2 decades,
Hello.
around 2 decades ago, when I used to read your learning modules, which you had written initially for IGNO, particularly MCA program, and particularly the topics like design and analysis of algorithm, artificial intelligence, and theory of computer science.
It's very kind of you.
Subject was considered as a most dry, difficult mathematical subject, but the way you presented that module, it was in such a self-learning mode that you start reading from first page and read till last page. You will never realize it was a mathematics. And every next page will create a temptation to read the next page. And that's how the people once they start would like to and would love to finish everything. So that beauty we also see in your lecture which you deliver. So thank you so much, sir. And this certificate was not for the purpose of certification as usual. You have no need to have any certificate, but only for the purpose of remembrance, that once you see this certificate, at least you will remember us. And thank you so much to all the participants. Yeah, Ayushi.
Well,
Memento as
well,
well.
1 minute, I'll take Professor
Oh,
Hoda.
please, most welcome,
This
sir.
certificate and your invitations and the participants of all participants, they are my life and blood. They are
Right.
the very for my being alive and actively alive also. This means a lot to me. Your participation, your invitation, and this certificate is very valuable to me. And I'm really thankful to all of you for remembering from time to time and giving this opportunity of interacting with the scholars across the world. Thank you very much. I have taken a lot of time. I always beg your pardon for taking too much time. Thank you very much.
But it's our privilege. It's our privilege to have you, sir.
So kind of. Thank you.
And there is a certificate and there is a memento for you. Electronic memento. It is a digital age, sir.
Thank you, sir. Thank you so much.
Sure.
I would now
Sure.
like to request Uttam, sir, to please present e-memento to sir, as there is some technical glitch from my end.
No problem. Anyway, Dr. Ayushi and Professor Hoda and other friends, yeah, thank you very much. I am really feeling honored by all these presents to me. I am really, I always cherish all these things. Thank you very much.
Memento in digital age, sir.
Thank you, sir. Thank you for joining us and giving time for us. Thank you.
So kind of you.
Thank you
Let
so
me
much,
take
sir.
your
Thank you
leave.
so much.
Thank you.
Thank you so much.
Let me
I
take your.
also would like to thank all our distinguished panelists and participants who have been continuously supporting us all through our webinars. A big thank you for joining us. Thank you all.